Hello Boguslaw, this is Itsu. I was intrigued by your new thread about the inverter from Della Morte. It happens to be I was also working on some kind of inverter for using 12 volt, making 22 volts out of it. And I was working on this circuit. It's basically the same circuit. It uses a PIC controller to make the 50 Hertz, and we have two MOSFETs going to a transformer and making the 220 volts. So this is the little circuit with the PIC controller in the middle and the two MOSFETs going to a toroid, 2 times 10 volts in and 220 volts out, and I hooked it up to a 25 watt to 30 volts bulb at the moment. And at the input we have two 12 volts batteries, 7 amp hour batteries. They are in parallel now, so we should have, they are a little bit exhausted at the moment, but we should have about 12 volts on the meter. I have hooked up one of my multimeters showing the voltage, and I have hooked one of my analog meters to show the DC current being pulled from this setup. And I will try to make some measurements now and to see a baseline before I will try to go to the next step. And this is your proposed loopback circuit, the inverter in the box, and then feeding the 220 volt back somehow to the input. But first I wanted to make some measurements on the inverter itself. It's a little bit different than yours, but it's in principle the same. Okay, let me hook up the voltage now and try to see some measurements. Okay, so the bulb is lit. It's not that bright, so it's not the real 25 watts, I'm sure. And this is the output. I have the red probe hooked across the lamp, the bulb. And this is the output. You can see the nice square sine wave form. It's produced by the two MOSFETs in the circuit. Zoom in. These are the peak-to-peak values. The frequency is made by the PIC controller, 51 Hertz, and some other values. But so this is basically the voltage coming out of the 220 volt side of the transformer. And on the input side we have here the 12 volt of the batteries. Almost 12 volts, so they are almost exhausted. And this is the amp draw. I have it now set on 5 volts, 5 amps DC maximum. So that would be this middle black scale. So we are pulling about 1 amp, 1.2 amps. And that would mean that we have something like 12 watts going into the system now. Nothing is getting hot, it stays very cool. These transistors, these MOSFETs, which are these MOSFETs. So this is a little bit the setup. I want to also show you the current across the, I have somewhere here a 0.1 ohm. Okay, I have hooked the red probe now across the 0.1 ohm resistor in the return line of the batteries. And when I start the system, the light is lit, but this is the resulting current being drawn across this resistor. And you see we have a duty cycle of about 50%. It's in DC coupling, so we are going plus. Frequency is 100 Hertz, 102 Hertz. And the point-to-point is not valid because we have this very nasty spike at the bottom. So when I go to the channel, it's about 100 millivolt per division. 1, 2, it is 2.5, 2, 3/4. So it's 275 millivolts across this resistor, which corresponds to about 2.75 amps. But it's 50% duty cycle, so it will be something like 1.3, 1.4 amps at this almost 12 volts. So that will be the input for the system, lighting this 25 watt bulb. Okay, this is the system what I want to try to get into this loopback system later on. Thank you for watching.